Okay, welcome back. So this is the second video of the day where we will continue our work on taking Solana apart. And so what we have done in the previous videos was setting up a isolated execution environment for SVM. And then in the previous video, we have set up a structure for how we're going to extend this with serialization. And in this video, we're going to finish that work using AI. Either we're going to finish it or we're going to fail, who knows? But the key point here is we're going to use AI to work these things out and try to get a design for SVM executor that allows us to invoke the tool from the command line, as well as decide, are we using the raw blob format for interacting with contracts, or are we using the anchor format? So with that, let's continue the work. So in the previous video, we came up with a outline for what needs to be done here. We got the LLM to develop that for us. And we did step 0, which was just reorganizing the repository to use this new structure. But other than that, we haven't done any of the steps. So let's just copy the plan across into a file. Just copy it into README for now. And see, okay, so we're done with 1 project structure, 2 implementational steps. Okay. Let's see, create a trait for the program invocation that all program types will implement. So that would probably be in the invoker. Normally, we could have asked the LLM to come up with some good suggestions to where to put these things. It's already made the structure, so it should be rather straightforward to do that. But let's just do this. And I think maybe the last one would need to go into utils, implement a factory for creating an invoker based. Yeah, okay, let's just run this and see what happens. So it has all of the context. It has our program that's working. It has the instruction data, account data. Let's see. So what does it want here? It has all of the... I don't know whether this makes sense. Okay, so program time, Solana, anchor. This is great encoder. That's blob, anchor, Bosch. I'm actually not entirely sure that this is correct. So we'll need to understand that in a bit more detail, what Bosch is used for. Maybe that is the way that you encode calls to... Okay, create encoder and config path. Anchor encoder, config path. So I guess the config path would be the ABI or ABL. Okay, let's just extend this. Could you one? Okay. So the reason why it's important to actually understand these things is because sometimes LLMs will make minor errors and it will make everything incredibly hard to get to work in the long run, because what will happen is that it takes these minor errors, it will mix things up, And so we need to understand what it's actually doing here, or what the thought process is. Thought process in quotation mark, that is. Schema definition file. Okay, so this not required can be none. Yeah, okay. And okay, so we were right, this is the IDL file. Argument encoder. And honestly, I don't know if this is program type anchors. Well, why does this even matter? I don't understand why the program type matters. It's just a .so file, right? So I think the only thing that would matter would be how we call this thing, but whether it's Solana or Anchor, from a program perspective, you should start the same place every time. Maybe I'm missing something trivial here. That's something to keep in mind. Okay, so that's useful to know. So Bosch is apparently the native Solana format. Okay, and let's go back to the files. And so that's the schema definition. Okay. This may or may not make sense, but it feels like we're learning something here. Okay, so to make sure that the LLM is aware of what we're doing here, I'm just adding the code we have developed. Oh, misspelled that. I thought I asked it to remember to import the dependencies. It clearly just ignores me. Wait, why is Anchor using Bosch? I thought this was separate. Program path, program ID, encoder. I wonder if this is going to work. Invoke. And so, oh wait, so it doesn't. This would be similar to like. Wow, this LLM is completely useless. It's not doing what I'm asking it to. Like, leaving out a very, very important part of the implementation is. And also, I only asked it to implement the Anchor encoder, not the other ones. Like, okay, this is just insane. Like, it doesn't get even the simple stuff. So maybe that's why we're having a Bosch encoder in the middle of everything. Program invoker. Okay, so that's the blob encoder. also, it was never part of the plan that you should do both. Like, so why does it do that? Anyway, now it's doing it, so let's just add it, figure out the details afterwards. But I really don't get this. Well, did I not mark everything for? Oh no, I didn't. And it just re-implemented the blob encoder, right? So I think this is a really great example where we have some context pollution, right? So somewhere in this context, we have things that makes it thinks it has to do things that I'm not asking it. Such a frustrating thing to have. Right, because now we have another blob encoder. We shouldn't have a blob encoder here. We should only have the anchor encoder, right? Okay, so let's just, so for whatever reason it thought that we hadn't done a great job at implementing the, okay, anyway, and here it did it right. And so these are, and here it did it right too, so that's good. Okay. Let's make a new context and see if we can correct from this state of doing things wrong. A plan. So it now knows that this is a plan, hopefully. Code we have developed. Manual example. Okay, so that is running. We add that there. Okay, I like this. That at least it agrees with us on what the client user interface should be. Let's see if it builds. I feel skeptical. Right. So there's clearly some error here. Let's go back to our first thing here and then just ask it what the problem is. So the thing is, we are overall pretty sure that the structure is good enough. We're sure that the overall intention is good enough. It still seems a little bit messy, what we're doing, but let's see if it can correct from here. Okay, we'll move this over into the README and then update the plan here. Okay, let's see. What is step one here? Step one. Okay, so these seems to be helper functions that allow us to create accounts and create a transaction. I guess that all makes sense. Then next step, step two. Oh, wait, right. So that was A. What does B says? Or B say? Blob.rs. Complete that. Yeah, okay. Right. complete Blob.rs implementation. Okay, looks reasonable. Oh, well, maybe it doesn't look reasonable. Actually, I didn't look at the code. Oh, fuck. I'm sorry for that. That was not... Just came out of me. There. Mm-hmm. Right. So Anchor has... Here we actually have the format from which Anchor is calculating the so-called discriminator. It feels like we should be able to make a alternative version of the Anchor implementation. It doesn't require an IDL file, but where you just give it the function name and the function types or the function signature on the fly. Maybe that would be preferable, because I have no clue how to get the IDL file out of this system. All right, let's see what's next on our list. That was step B. Cool. Step 2, implement account generation logic. Could you implement step 2B, 2A, right? Yes. And it was in Invoker. All right, let's do this. I will hit enter. So there's a chance that it already did this when we asked it to implement utils.rs. There's also a chance that it didn't. Time will tell. Okay, so there's definitely changes to be made here. Implement Solana Invoker. Now, why would it do this? This just seems like a wrong design, right? You're creating a runtime inside a function, and then you're calling async functions. So you're basically taking an async program and making it synchronous. I guess it will work for now, but it ain't pretty, that's for sure. Okay, let's see. I think this one was in Blob. I must admit, I still feel somewhat puzzled about that we have different invokers. I would imagine that we only have a single encoder, right? So what I had in mind was that we have a list of encoders, but other than that, it's always the same SolanaVM and the Solana execution engine we're running. So I'd just imagine it to encode everything into a blob. And the reason why we have blob to start with is because this should be the easiest to implement, right? So you have that Solana takes a blob on the entry point, and the entry point would just take that blob, execute it. But it feels like there's something I'm misunderstanding here. We will get to the bottom of this. There's something I don't quite get. Right, so now it sets up accounts, does some other things. It's probably good enough. Let's see. What is our next step? So right now, I basically just want this to compile such that I can start figuring out what is actually going on here. Okay, so now we also have the possibility of adding accounts from the command line. This seems completely over-engineered. Okay, well, I guess it's something we would want to have eventually, but like I just didn't think that we should do this now. Doesn't like default accounts would have been enough, so I don't see why it changes the plan. But as I said, it's something we wanted eventually, so let's just go for it and then take that extra pain of getting that to work as well. Now we have updated the main, so surely we must be finished now. Oh wait, no, there's still quite a lot left here. Oh, no way. There's no way that I'm going to add any debugging thing. I just wanted to compile. Okay. Okay, so it's reasonably... Let's start by doing the simple stuff. That was anchor. need the same ones in Blob. Okay, let's just forget about this Bosch thing for now. I actually don't want it. Okay, so it feels like that this should be separated out, right? So we have the trade and we have the factory. Those things should not be living in the same file. So I would probably move that out eventually. Just create argument encoder. I'm actually starting to be a bit suspicious here. Could it be that this program never worked in the first place? Where does this Anchor program processor coming from? Where does this one get the .so file from? I am super confused. In the first VM executor we made, we manually loaded the .so file. In this one, it appears we do not. What did we call the example again? Manual. Final account length, blah, blah, blah. Right, updated value to 100. So we are clearly calling the program, right? Oh, wait. Oh my fucking god. Is that what's going on here? No fucking way. It made an exact replica of the program inside of the program. So it actually never solved the problem in the first place. Oh my god. Okay. New plan. Okay, so let's just walk through what happened here, because this is super embarrassing. So basically, we created a anchor program, which is in here, and it has these things where it says initialized account with value, updated value too. When we asked the LLM to create a version where it loads the program, it did not actually load the program. What it did instead was it recreated the program inside of the program with exactly the same thing. So when you would run the program, it looked like it was running the program, and so you're being misled. It's actually not doing any of that. It's just wasting my time. This is so disappointing. So disappointing. Let's see if we can fix this. Right. Actually, let's just do one thing before that. Okay, so you see in this first version, we had this place where we're checking for the compiled programs and checking the metadata. Compiled program found, right? So possible paths. But does it actually do anything with that? Let's just see. Muck. Does it muck anything? Let's see what happens if we do cargo run. Okay. So I'm pretty sure that this one used to print out program executed, right? But it also used to print out logs from the program. Let's just try to check what's in the simple program here. Right, so somewhere simple program executed, it should say somewhere number of accounts. Oh my god, this is one big fake. So basically the previous work we did, we should have been more careful than just comparing text, because this is also a fake program. Okay. So this is wrong all the way through. It actually never loads the actual program. This is a complete disaster. Okay. So we're going to take one step back and we're going to fix this. This video is taking a completely different turn. This is not where we wanted to go, but this is where we are. We're going back to where we were and actually just getting the basic thing to work. But instead, we'll make another example here. New folder, simple. And inside simple, we'll make main. This is so disappointing. So disappointing. Like I can't believe this. Okay, so back to the drawing board here. Let's see. We have the simple thing here. SVM. SVM executor. Expected function pointer. And this one I think we already established does not work or does not exist. What dread? I fear that we might have to actually read the documentation. It's not what I was hoping for, but I think there is no way around that. Also, it appears to me that it shouldn't be using program tests, right? Okay, so we have the EBF VM here. And that would be the one that we use for okay, but this actually has a lot of really good information. Anyway, this is the one prefer BPF. Yeah, okay, so an add program, add built-in program. Right, so the idea here is probably that you can add various programs to allow you to test such things as cross-contract calls and whatnot. But I want to load a start with context. think this requires me to sit down. Let's try to take one step back and just search for. So it would make sense that Solana program test would be for built-in programs, and then Solana program might or may not. Oh wait, that was the source code. I don't want to read the source code. I want to read the docs. Process instruction entry point. So this creates a okay, and here we get the answer to what we actually wanted to know. Bosch seems to be a serialization framework that they're using to find the account information. Okay. Right, and so we start with the entry point in all of these programs. PFP loader. Okay, so this seems to be what we want to have. Okay, but that's a native program, so maybe that's not what we want to have. Okay. But this is not going to work, right? Because we have just looked at the documentation and that one says that it expects a built-in function option, right? So this is just ridiculous. Okay. This is a little disappointing. Well, actually, it's a lot disappointing. But it goes to show that you should never ever trust your LLM to implement things right, not even if they on the surface look right. Let's just try to. Okay, this seems like a very useful post. Data entry point, and then the entry point is responsible. So this is what we worked out. Like, this was what we worked out in our understanding of it yesterday. That's exactly how it works. So you pass data into the entry point, and that in turn is okay. Let's save this thing. That seems really useful. Okay, and so this one also seems to be programs, loaders. Right, and so what we want is the executable, and we see program execution RBP program deploy. I don't care about how I deploy it. How do I load the bloody thing? Transaction context, program cache, environment, yada yada yada. Okay, invoking the. So that's done in a context. Okay, let's find the conversation we had with the thing yesterday. SolanaVM. Oh, so it has. Let's just go a insane amount of steps back here. Let's take this thing, replace it completely, and just say we do this with SVM runner. So this is our simple program. Okay, so in this one we read the program directly. Let's just paste this right in here. So we're just deleting this, moving all of this out. There is some replication here now, but who cares? Let's see what happens if we run this. Yeah, so it's just complaining about all the replication that we have. Hash map is replicated. Account is replicated. Instruction is new. Message is replicated. Pub key, signer, transaction. Basically, this is the only thing that survives. And that's it. Right, and even instruction is re-imported, so that's okay. Okay, no such file or directory. So let's now try to define target grep.so. Right. That one is under programs. We don't want the anchor example, we want the simple program example. Okay. This does seem like real progress though. Checking the state before execution, preparing. Okay, but that seems like a solvable problem. Right, at least now we're loading the right program. We are So why would it just remove all of this code? I absolutely love it. Like, this is a LLM solution to how you get rid of an error. You just delete the code, like obviously. Like, what else would you do? Well, actually, let's just try it and see what happens. Okay, I'm having a hard time being enthusiastic about this because it feels like we've gone so far back, but it does execute something. Like incrementing. Although, let's just be super careful here. Right, and we're checking the value afterwards, and it does become 1. We create, but are we actually executing this? I do not trust this one little bit. Why does it say simulate program execution? It should not simulate anything. It should just bloody do it. Get accounts. Okay, so what does it do here? I don't. It actually gets the account mutable. I can't believe this. It's basically doing the exact same thing again, right? It does not execute anything. Right, okay. Let's take another step back and then just have a look at, I think this was the thread we had yesterday. Load program binary. Okay, so this one actually does load the program into memory. I wonder if this is the one. So we had one yesterday that kind of did what it was supposed to, but then it broke down because of Genesis. Of some Genesis mismatch. No, that was Stakers that was missing. That was the issue. So let's go back to whatever program that was and just see. Okay, so this one we still had some issues. This one we had some other ish. Yeah, here we go. Right. So this was the one. Genesis processing failed because no staked nodes. So that means that must have been this program that actually worked, or kind of worked. Let's copy that one back. And just try to run that one again. Okay, so initializing the VM, we're getting this error. Now it loads the program and it tries to initialize the SVM. Let's try to run this with the Rust backtrace. So main 41, that's where we break down. Oh wait, that's where we return. I see. Before that though, it's main 106. Which is this one. So that's the one where it complains about the Genesis. Okay. Or rather, it complains about the staking. This seems like a good starting point. Okay, let's try to now go back here and set version 5 worked. Version 6. Transaction. So we don't use any of the testing stuff here. We're still loading the program. We're still returning bytes. And at this point, we're looking to build a bank, but for testing purposes. What do we do in the other programs? I just wonder. I see. So seems we completely avoid this issue altogether. And so this is the point where we changed. But now it's no longer, right? So let's just write. You're right, the API has changed significantly. Let me try to provide you with a working solution using which recommended and using stable. Okay, but the good thing is we have a thing where it should be loading the program, right? So if we're looking here, this is the wrong file. If we're looking here, it should be loading the program. Set up program bytes. What do we do with those program bytes? Create a new shared account. And so we just load them in there. Okay. That seems so unhelpful that we're doing that. So we basically expect the VM is, this is not at all like EVM where we can nicely isolate the entire executable VM from the rest of the system. This is way more involved. Right, and then we store the program and then we expect the VM to load the program from the bank to execute it. I see. Okay. This is more complicated than I anticipated. Let's get back and maybe try to read some more documentation. So that one has a banks client as well. I wonder, could we maybe... invoke context, program, test program. Is this something that's just bytes? No, it appears not. Set transaction, login limit. Okay, but this one is actually having built-in program mock. This one has an example of how we do a program. So here we can get an executable from the loader. We specify the version, the function registry, and we create a context. We have some memory and a stack. Wow. Now we're getting to something that actually seems an execute program executable. Where's the executable defined? Okay. So here's what we're going to do. We're going to use this as an example for our LLM to build up a example, and we're going to make a new example in the code base just using this. This is simple enough that I actually understand what's going on here. And this gives us low-level access to the VM. Like all of these ones are public. I can get behind this. This feels doable. Right, and so the executable just starts wherever the executable starts with this thing. Let's try to do that. Okay. Okay, so new plan. What we do is we'll feed this LLM and ask it to make a very simple example of loading an SO file and then executing that. And then hopefully that will provide us with something more useful. the meantime, I am so disappointed that the other thing did not work, but clearly we've started on a too high level. We've started out with the full system basically for doing things, because it wanted to write the program into a memory bank, and the memory bank then load it from the memory bank via the yeah, via the VM interface, which, but I just can't get over that it just replaced the actual implementation we wanted it to do with a mock implementation. And because it was a complete replica and we only looked at the output, we did not see that, or I did not see that it was actually something completely different. Okay, so what does it say here? Yeah, we have these dependencies. Program path, okay. Read the file. Creates a new public key. Creates a new VM from the program bytes. That's lovely. That's lovely. Okay, this is what we want. Just creating another folder here. Let's see, so my okay, we need to Okay, so I think our goal for this video is going to change. We are simply just going to get this to work, and once we have that working with VM, we're going to stop. And then we'll have to pick up on this and redo the other pieces again. Like overall, I think that the plan that we came up with for the loaders makes sense. I'm still not entirely clear how much work we still need to do to actually get to where we want to be. Clearly, there's been some bumps in the road, but I think for the better. Like this actually feels a lot more like some of the work I did with EVM, so it might not be too bad, even if I'm a little bit annoyed that it didn't work out from the beginning. But there you go, like this just shows the importance of reading your code or reading the generated code and really understanding what it's doing before celebrating your success. Okay, we might need to add some features here because I'm pretty sure that oh, that's in test utils. Right. Just that seems like a very generic name for crate. Let's just go back to the context we had. Oh wait, that was the wrong place. Okay, that may be. So it's still complaining about this, and I also think that's not what's in the doc, is it? That is just, in fact, the program loader build in. That's so strange. This seems completely off from what's in the documentation, doesn't it? Right, because we regions executable get where did we actually define the executable here? So that's defined there, right? And that's loading. Okay. Let's do something where we have a bit more control over the context. Okay, now it loads a lot more stuff. We see it now. Does the new muck, it adds the bytes to the, and then it creates a instruction. Okay, let's see. Will we laugh or will we cry? I guess we'll cry for a little bit of time to come. There's still more to be done here. Okay, and so clearly the crate that's in the example is not really what we want. And to make things even more frustrating, there's basically no mention of this test context. Right, and we even Google, this is the first thing that comes up. Okay. Okay, but here we have the actual struct for the, okay, let's just going to copy this across and forget about that we ever imported it. What the hell? It's not supposed to copy the line numbers. Why would it do that? Really? Okay. That's different though, right? So here we're adding with context. Why would it do that? Okay, so it's trying to be helpful with the debugging, it seems. Just get rid of this. I'm not even sure, was that... Just, why would it add that with context? I don't think we have that anywhere, right? So it just has this... Oh, so that's... Like, this makes absolutely no sense. I've copied a piece of documentation and it thinks from that it infers all sorts of stuff that isn't true, right? Which just goes to show that you need to be super deliberate with right, and so that's not even in the documentation I copied. It is when you fetch the entire web page, which we just did. So let's just get rid of that. Could you make sure you follow that documentation closely? So it has added a lot of other things that might or might not be useful, like for instance this trace lock. I don't know whether it works, but if it does, it seems like something that you want to have. Oh man, I am starting to feel very tired. Okay, there we go. That's where it's located. Right, and it's in error there. Hey, the program compiles now. Okay, target deploy slash .so. Okay, this seems like progress. Reloading the file. Verification ID. Invalid function. Okay, let's see. Where do we panic? Backtrace. Load and execute program. So we successfully loaded the program, didn't we? We got a program ID. Okay, verification failed. I think that was a bit, wasn't it? Verification failed. Why do we need to? What does this even do? And do we do that in the example that we found? Verify. We do verify things. Okay, I think will be where we stop the live stream for today. This is a big fat fail. We tried a lot of different things, and because we weren't careful enough in the beginning, we've been going down a route that we shouldn't have gone down. We're now back on the right track, but there's still a lot of basic work to be done here. So once I've figured this out, we'll pick up the pieces and we'll go on, we'll get this built and get it working. Because I start to feel step on now. This just have to work.